Hi all. In this video, we will continue from the previous video. Now we are going to understand what is core LLM or core large language model concepts. So the basic concepts involved here are transformer architecture. Transformers are the deep learning architecture behind all model languages like GPT, BERT, and Gemini. They process input text in parallel instead of sequentially, making them faster and more scalable than other RNNs. The core idea is attention, which allows the model to focus on relevant words in a sentence. This architecture revolutionized natural language understanding and generation. Second concept is attention mechanism. Attention helps the model decide which part of the input are most relevant when generating a response. For example, in the sentence, the cat sat on the mat because it was tired. The word it will refer to the cat. Attention assigns higher weight to important words, allowing the model to maintain context. It's the secret behind how models understand long and complex sentences. Context window basically is the maximum amount of text an LLM can consider at once. If the window is 8,000 tokens, the model can only remember that much context before it forgets earlier parts. Large context windows means better understanding of long documents and conversations. However, increasing it requires more computation and memory resources. Next concept is temperature. So temperature basically controls how random or creative the model's responses are. A low temperature or 0.2 makes answer more focused and deterministic, which is good for coding or factual replies. A high temperature like 0.8 produces more creative or exploratory answer, which is more useful for brainstorming and storytelling. Tuning this parameter helps balance accuracy and creativity. Next concept is prompt chaining. Prompt chaining involves breaking a complex problem into multiple smaller prompts that feed into each other. For example, an agent must first summarize a document, then extract key point, and finally create an action plan. This step-by-step structure helps maintain context and accuracy across multi-step tasks. It's heavily used in building a reasoning-based agents. Another concept is top K and top P sampling. So these are sampling methods basically which used to generate text creatively while avoiding nonsense. Top K basically is choose the next token from the top most probable words, while top P selects token whose cumulative probability is higher or it reaches P. Together, they make responses both coherent and diverse. They're essentially for controlling text generation. An example would be, for example, if we say the cat sat on the, we can have mat, sofa, floor, roof, tree, etc. But the most top three probability is for mat, sofa, and floor. So this is top K where K is equal to 3. Top P basically means that if for mat, sofa, or any other thing, the probability addition of those probability is higher, then the model will give those things as response to us. Next concept is few shot and zero shot learning. So basically this concept is that it is giving the model a few examples before asking it to perform a similar task. That's a few shot. And zero shot means the model performs a task without any prior example, relying only on instructions. These abilities show how powerful LMs have become, as they can generalize to new problems without retraining. This makes them extremely flexible for real-world applications. Next concept is system prompt. A system prompt sets the behavior, tone, or role of the AI before it starts interacting. For example, you might tell a model, "You are polite financial advisor." It means that it will respond accordingly throughout your interaction with the chat. It acts like an invisible rulebook that guides all outputs. Developers use system prompts to ensure consistent behavior across the session. Next concept is tool use or function calling. Function calling allows LLM to use external tools or APIs to get real-time or specialized data. For example, an agent can call a weather API and ask, "What's the temperature in America?" The LLM doesn't generate data, it decides when to call the tool and interpret the result. This makes LLM far more useful and connected to the real world. Next concept is RAG, Retrieval Augmented Generation. It combines an LLM with a knowledge base like vector database. So instead of relying only on its training data, the model retrieves relevant documents at query time and uses them to generate accurate, up-to-date answers. For example, a RAG-based system can answer company-specific questions by fetching internal documents. For example, how many leaves are there in this month? So LLM will go to the leave calendar and fetch the number of leaves of this month. This approach enhances accuracy, transparency, and domain adaptability. So these are the primary concepts which we have to understand to get a deeper understanding of how agentic AI or LLM works. Thanks. That's it for this video.